All right, let's go and get started. What were we talking about again? I feel like it's just been so long since we've all met. It's insane. Before we begin, I guess I must apologize. We didn't have class last Tuesday because I was away at a research conference, and the conference was in Orlando, Florida. So I apologize that I did not bring the warm weather back with me. I feel that what I actually did was took our warm weather down with me there and left it there.
Because they need it, right?
Yeah, because so yeah, I'm feeling more and more guilty about that trip as the days move on. So, well, I don't know about that. Real quick, let's go through a few announcements before we get into this. Actually, our topics of discussion today are probably not going to be very long. We're going to sort of finish everything out associated with the Casio, and then we're going to spend the next few weeks really digging into one of our two big software packages this semester, which is Excel. So a few things. Number one, let's see. So I have returned homework 1, and I think I got it back to most of you. I think there were a few folks that trickled in. Anybody didn't get theirs? Let's see. All right. So Mr. Adams. All right. There we go.
Sure.
All right. And then Miss Stedman. All right. I've still got a couple more up here. Anybody else? Okay. Mr. Sutton. Okay. And I think the others, I guess we'll just sort of hand those out as everybody trickles in. Okay, so there's that. Let me just really briefly go through the solution on that with you so that everybody kind of has an idea. If you look on Blackboard, what you'll see is there's a folder on Blackboard. It should say something like old homework assignments. Does everybody see that? And if you look, there should be a PDF of the solution. So, because I just, what the heck, I'll just go ahead and give you all the solution. So, I'm just going to walk through this real quick. Most of the stuff on the assignment was graded, I'd say, pretty leniently. But I'll walk through a couple of them. So, for instance, these order of magnitude estimates. So, here's how we went about this on the solution. So, if you go to Google and you search, what is the distance from Huntington, West Virginia to Los Angeles, you'll get that trip takes 2,281.6 miles. So a round trip would be double of that, which would be 4,500 or so. So from an order of magnitude estimate, we're looking at the thousands of miles. That's where the 10 to the third comes into play. Now for mileage, you could probably assume just about anything. I went with 20 miles per gallon, but ultimately we're looking at mileage that's in the tens, 20 miles, 30 miles per gallon, etc. So divide that out, and in terms of the magnitude of fuel required to get you to Los Angeles and back, we're talking about hundreds of gallons. That's where the 10 to the second power comes into play, hundreds. Now, if you go through and actually do the math, that's actually what comes out. You get 228.16 gallons. And the same thing with the age of the state of West Virginia. So what I did is I took the age in years and multiplied that by 365 days in a year. So the age in years, I got 154, which I guess it's actually dependent, when the homework, this is more like 153 and a half because West Virginia was created in late June. Bless you. But by and large, we're talking about a number of days that's sort of in the 10,000. So we got 10 to the fourth days, which if you actually calculate that, we get 50,000 or 56,000 days, 56 and change. So yeah, so that's sort of the by and large of the magnitude estimates. Now, I'd say I don't want to say the mistake, but the big maybe sort of issue that popped up on a lot of people's homework was things like the unit conversions and things like the display of appropriate values needed to be in the correct number of significant digits. Now, what I told the TA to do was let's take problem number 4. A lot of folks, what they were doing is they get 42 miles per hour, for instance. If you convert that to meters per second, you get 18.7757, what have you. But in significant digits, really, that should just be rounded to 19. what I told the TA to do was instead of counting each individual problem wrong or taking a point off on each one, that'd be 12 points off on the whole assignment. I told the TA to give you kind of like a Sam's discount and just take maybe a few points off on everything so it wouldn't hit you as hard. But yeah, that was really the one big thing that I think kept popping out was just rounding your answers back to significant digits. Other than that, I think everybody for the most part did pretty well. I don't think there's any real big comments or any big things to point out. I went through and also I've got sort of a sample, I guess, derivation for these four dimensional analyses. You should have gotten that the first one and the last one were dimensionally accurate, but the last two, or the ones in the middle, are not. Like, for instance, on number 2, you get newtons equals newtons meters, so it's not dimensionally accurate. But the first one and the last one are. And then I have sort of a step-by-step on the linear interpolation ones for problem 6 and problem 7. With problem 7, we had an example like this in class, but the big thing is to just, you have to interpolate between these two, interpolate between these two, and then interpolate between those two results. And the answer you should have gotten at the bottom was about 0.08528. Anybody have any questions? Is everybody able to access that? Everybody able to get that? It's like I said, there's a folder on Blackboard that says something like old homeworks, and it's attached to that homework 1. And that's my plan, is to just do that for all the homework assignments throughout the semester, so that way you have the requisite material and whatnot. Sound good? Okay. So it's been a while since we've met, but we did have, I guess, kind of an online lecture last time. Was everybody able to watch that and go through that? I think that actually went through a lot of the nuts and bolts associated with the modes and various aspects of the Casio. Now you have a homework due on Thursday, which there's probably, as of now, there's like what, 1 or 2 problems on that homework assignment we still haven't covered, things like table and things like some of the mode functions. That's what we're going to talk about today. But by and large, you should be good on the homework. But since I'm talking about it, does anybody have any questions about the homework? One thing I will say is that this homework, I'm really more interested in your abilities to just use the Casio, so I'm not that worried about significant figures on this homework. Like last homework, I was a little worried about it because it was really what we're talking about. This one, I'm assessing your ability to use this. So if you do a unit conversion, you're literally just writing what's on the display, that's fine, okay? So everybody all right with that? Any questions? Okay. I did a little bit of work on MU Online. I wanted to point you to a few different things. So number 1, I posted the manual for this calculator on Blackboard. So we're not going to have time to talk about every single button and every single menu and every single option, but it's there. So if you want, you can go through and look into that. I also posted this. There's a document that the IT department at Marshall posts that tells students how to install a complimentary version of Microsoft Office onto their personal laptops and machines and whatnot. I mean, regardless of this class, or if you even still want to be an engineer after all this, you all should have Microsoft Office, period. I mean, whatever you decide to go into, engineering, accounting, nursing, sociology, what have you, Microsoft Office is an indispensable resource, and you all as students get a copy of it for free. So if you have a laptop and you haven't put it on there, do so. I mean, it's invaluable. And I posted, it's really just a pretty neat step-by-step process on how to install it. I also have all the grades posted as of today. Now, what I've done is I posted this homework assignment's grade. I've got the attendance as of today posted, and I've also got it computing your running class average. So keep in mind, attendance is part of the grade. So, if I'm updating the attendance every day, your running grade will change. So, for instance, if you're here today, then your attendance grade will go up, so your class average will go up. But I wanted to give everybody just sort of a general idea of where they're at in the class. I did this in Engineering 103, I think, as well. Like, there was a point when I just said, okay, here's all the grades, and everything was there. So if you want, you can sort of check that out. Sound good? One final thing I'll point out, so the Michael Fitzwater Engineering Scholarship, this is really for the SAME, ASCE members in the room. You need an SAME member number in order to apply, but that deadline's tomorrow. It's actually, technically the deadline is today, but I asked some folks at the court if they would accept applications tomorrow, up until tomorrow, and they said yeah. So if you're interested, has anybody received emails about that if you're an SAME member? Have you received emails about that yet? Okay, I'll send some messages to the officers in SAME, but yeah, my goal is that they get that out like now. All right, any other questions? Okay, so today what we're going to do is we're going to finalize our discussion on the Casio. Oh, one other thing. I did mention, I think earlier in the semester, that we might have some visitors coming into the classroom. Bless you. Did y'all remember that? We're probably going to have our first visitor on Thursday. So if you see some random professor walk in, don't go, what are you doing here? That they're supposed to be here. Just yeah. So we'll just sort of carry on. Okay. So let's get into our discussion regarding Casio. So let's see. So you all should be able to follow along with this on Blackboard. So this should have popped up today. Is everybody able to attach to this? Okay. All right. So what we're going to do today is we're going to finish out our discussion of modes associated with the calculator. Last time we were looking at mode 5, which is equation solver, and we had done 2x2 systems and 3x3 systems, and that was discussed on the video. Am I correct? Yeah. And then what we didn't have time to discuss was quadratic equations and cubic equations, which is 3 and 4. So we'll go through this pretty quick, but just to give you, again, a little bit of background, if you're solving just any random equation, the solve command is best. But if you're solving something like a quadratic equation or a 2x2 system, something that you as engineers are going to be solving over and over and over again, then using the equation mode is going to be what you're going to want to use, just as there's a lot less typing and everything's sort of really neatly programmed. So let's start off with a quadratic equation. I'm going to take a wild guess and say everybody in this room has seen a quadratic equation before, something like 2x squared plus 3x minus 9 equals 0, solve for x. So what is it? X equals negative b plus or minus square root of b squared minus 4ac over 2a. Everybody's aware of that? Good. Nice thing about the Casio is it's already built in, so you really don't have to do any additional work. You just go to the appropriate mode, plug in your values, and there you go. So I'll give you sort of an idea of how this works. We're going to use the following expression down here. So we've got x squared, or following equation, x squared minus 6x plus 4 equals 0, and we're going to use the quadratic mode to go through this. So I'm going to hop back and forth between the calculator and this. So I've got my little pop-up display open. Let me bring up my little key log, so that way you all can kind of see what buttons I'm entering as I enter them. So I've got the calculator. Remember, we're going to the mode menu. So if we click that button right here, that brings up mode. So your display should look something like this. Oh, my PowerPoint went away. There we go. And we're going to go to mode 5. So we press the number 5, and that puts us in equation mode. And then we're looking at quadratic equations, so we use option number 3. And so what you should get is a table that looks something like this: a value for A, a value for B, and a value for C. So all we have to do is enter in the appropriate coefficients behind these terms. So A would be your quadratic coefficient, B would be your linear coefficient, and C would be your constant coefficient. So what's A going to be here? 1. What's B going to be? -6, and C is going to be 4. So all we have to do is we type in 1, hit enter. Now for -6, we don't press -6 because the calculator views minus as an operation. Well, in order to change the sign, we use this button right here above recall. So you should see like a negative sign inside these parentheses. So -6. Then press equals, and 4, press equals. You should have a display that looks something about like this, right? Everybody got that? Okay. So once you've got that, all you do is hit equals, and that's all there is to it. And it does all the quadratic expressions for you and summarizes it in a very nice, neat format. So our first root for this equation is 3 plus the square root of 5. So if 3 plus the square root of 5 is the form that you like, hey, go with it. But maybe that's not what you want. Maybe you want a decimal value. Remember, if you want a decimal value, remember this S to D button right above the delete and AC keys? That will convert your answer into a decimal equivalent. So 3 plus the square root of 5, the square root of 5 is about 2.2 and change, something like that. So 3 plus 2.2 comes out to about 5.2. So there's your first root. You can press equals again to get your second root. So that's 3 minus the square root of 5, which that shouldn't be all that surprising. I mean, you have 3 plus the square root of 5, 3 minus the square root of 5. You know, that's should be a fairly familiar type of result if you've done quadratic equation problems before. You know, you've got negative b plus or minus square root of b squared minus 4ac. So that plus or minus pattern should be fairly familiar. Again, S over D or S to D key to change that to a decimal value. Sound good? It's not too bad, right? Pretty straightforward. All right, I got another one just to make sure we're all clear on the practice. So if I hit equals, again, it's giving me minimums and maximums and what have you. We really don't need to worry about that. But as soon as we hit equals a few times, we're still in equation mode. So we can go through and just solve another one right now. So if our next one is, you know, 2x squared minus 3x minus 6, I can go in and start entering those values right now. I can just go, you know, 2 minus 3, so again use that minus sign, and then minus 6, and then hit equals, and there you go. That's it. It's not too bad, right? So you should get 3 plus the square root of 57 over 4 and 3 minus the square root of 57 over 4. So far so good? Now, let's see if y'all remember. How do I get the calculator back into its standard operating mode? Mode 1, exactly. So the calculator will remain in equation mode until I get it back out of it. So if I hit mode 1, now it's, you know, back into normal operating procedures. Sound good? Any questions? Good stuff. All right. So that's a quadratic equation. A cubic equation is basically the same thing, only tacking another polynomial term. In this case, we're looking at x to the third plus something x squared plus something times x plus something d. So we have cubic coefficients, quadratic coefficients, linear coefficients, and constants. So we've got 4 terms. But the operation or the operating procedure works exactly the same. So all we have to do is, you know, if you went back to mode 1, then we've got to go mode 5 to get us back in equation mode. And in this case, we're looking at mode 4. Okay, so we're looking at cubic equations. So again, another table, but if you use the arrow keys, you're going to see there's an A, B, C, and a D. So we're going to have more values to enter. So we'll use this equation down below. So we have x cubed minus 2x squared minus x plus 2. So our coefficients are going to be 1, minus 2, what here? Minus 1, negative 1, and then 2. So we can say 1, then we've got minus 2, minus 1, and then 2. And once you enter in your last value, again, you can use those arrow keys to go back and forth and just make sure that that's right. If you wanted, you could go, you know, like you could go over here and say, oh, that's got to be something different, and then hit 1 and, you know, hit enter or something. So you can go in and overwrite those values. Also, the next time that you use equation mode, those constants are going to still be stuck in there. So if you only need to change a few of them and don't have to change all of them, you can just use the arrow keys. Once you've got everything programmed in, just hit enter, and there you go. It starts spitting your roots. Now, this is a cubic equation, so there's going to be 3 answers. So one of them is negative 1, one of them's 2, and the other's 1. Okay? Everybody getting that? Everybody get? What's that? Well, it will give you an x minimum and a y minimum in addition to that with the quadratics. But in terms of your roots, you're really not interested in that. Really, all you're going to be interested. Well, that's a good question. The answer is no, because that's not going to be the solution. The solution is just what are the values of x that generate a 0 in that equation. So no, we're really not interested in that. And I'll be honest, by and large, I don't know that I've ever really been interested in that in any of my classes like since. You know, I'm really just interested in the roots. That's a good question, though. Any others? This is good stuff. All right. Now, if we want, here's just another equation that we can utilize. Now, again, this is sort of emphasizing what I was mentioning before. If we want to solve another cubic equation, so now we've got x cubed minus 2x squared minus 2x plus 2. If I wanted to solve another one, I'd enter those coefficients. But notice this one's 1 and it's already 1. So I don't need to enter it again. And this one's -2, it's already -2. So I don't need to enter that one in twice. All I have to do is say, okay, well, the only ones I really need to change are the c and the d. So move over to c, and let's make that, what is it, -2? And then this one needs to be 2, but I don't need to change that one either. Everything else was correct. The only thing I needed to change was that c one. So I'm lazy. So instead of typing them all in, I'll just type in the only ones that matter. Sound good? Once I got those all in, just hit equals, and then there we go. Now, because cubic equations are a little more complicated to solve than quadratics, you're more than likely not going to get a very, like 3 plus square root of 57 over 4, a nice contained algebraic expression. Because the solutions are a little more complicated, by and large, the calculator is probably just going to spit out a decimal answer. Like there's no fractional answer available. It's just -1.17, what have you. So that's x1. x2 is about 2.48, and then 0.69, something like that. Any questions? Shouldn't too bad, right? All right. Okay. Everything else good? Okay. Now, the only other mode that I really want to discuss, and this is a pretty nifty mode, not just for what you're doing in engineering. I mean, I'm sure this will probably help when you're looking at stuff in calculus, stuff in physics, maybe even some of the other sciences like chemistry, I'm not sure, but calculus and physics really come to mind. The table function will work a lot like Excel later, but by and large, the point of it is to take a given function and basically just start computing values for that function, ultimately to try and graph the equation or plot the equation. So let's go through a basic example. Okay, so let's say we've got the following function, f of x equals x squared minus 2x plus 2. So before we go any further, if I graph that equation, what should it look like? It's a parabola, right? That's a y equals x squared. It's a quadratic equation, so parabolas have that sort of U-shaped curve. Now, is that parabola, let's test your graphing skills a little bit. Is that parabola going to be opening upwards or opening downwards? Upwards, because the quadratic term is positive. There we go. All right. So what we're going to do is use the table command to see if we're getting the same answer. So let's just sort of walk through this. So the first thing that we're going to do is enter in the equation. So let me see. So let me go to mode 1. Let me clear all this out. Let me clear out my keylog. Okay. So to get into table mode, we're going to go to mode 7. Okay, does everybody see that? All right, now what will happen is the first thing that you'll see is it's asking for an f of x. It's asking for a function, okay? So the function we're going to enter is, x squared minus 2x plus 2. Okay, so again, we use our alpha command and just sort of work that through. I've got the keys down here if you want to follow along, but essentially what I'm doing is I need x squared, so I go to alpha, and then right here, the right parentheses, if you look above that, that's where the x is. So alpha x, excuse me. So that's x squared minus, so 2x, so we've got 2, and then alpha x, and then plus 2. Everybody got that? It's not bad, right? Okay. Now, what's going to happen is this. When you press equals, you're going to see g of x. Does everybody see that? Everybody got that on theirs? Okay, the way that the table command works in the Casio, you can print 2 equations at the same time if you want. Okay, so I really don't care about that right now. I just want to look at one equation at a time. So I'm just going to skip it. Okay, so but if you want, you can, bless you. But if you want, you can plug in another equation and graph 2 at the same time. I'm just going to skip it by hitting equals. So if you see that g of x pop up, it's just because the calculator wants to do 2 at the same time, but you really don't need to. Okay. Now, when you do that, you should have something pop up, look something like this, right? Okay. So let me explain what's going to happen. You're going to get 3 things pop up. You're going to get a start, an end, and then you're going to get something called step. Okay? So ultimately, your displays will look something like this. You'll have start, end, and step. Okay? So to give you kind of an idea, let's say I had start and end go from 0 to 10. And then my step was in increments of 2. So what the calculator will do is it will compute values from 0 to 10 in increments of 2. So 0, 2, 4, 6, 8, and 10. Does that make sense? For what I want to do, I'm going to go from -2 to 4, and I'm going to go in increments of 1/2. So I'll get a value at -2, and then I'll get a value at -1.5, and then a value at -1, -1/2, 0, 1/2, 1. See the pattern? Okay, so let's go off of this. Let's see what happens. So we'll go from -2, so remember the negative sign, so we'll start at -2, we'll end at 4, and we'll step 1/2 or 0.5. Now when you hit equals, you should get something that pops up looks like this. Is everybody getting something like that? Everybody got that? Okay. What the calculator has done is it has produced a table that looks something like this. Okay? Essentially, for every value of x, -2, -1.5, -1, so on and so forth, it computed that equation. So it said, x is -2, what is x squared minus 2x plus, or minus 2? So this squared minus 2 times -2 plus 2. And you go through and check it out, and you'll get an answer of 10. So it went and did that, all that repetitive calculation for you, just like that. All right? Make sense? You can use your arrow keys, and you can say, all right, I can start trailing that down, and I can start writing those points down. Literally write it down on a sheet of paper. And the nice thing about that is if I take that table and I plot it, I get something that looks like this. So I can literally say, okay, -2, 10, so -2, 10, that goes about there. -1.5, about right here, 7.25, somewhere about right there, and just start connecting the dots. So let me ask you this, does that plot look right? It's a parabola, right? It's a quadratic expression. You told me it was supposed to open upwards, right? Now all the data is there, you just have to go through and plot it out. It will save you a lot of time on something like a homework or a test. If you're trying to, you got some function, you need to know what it looks like. There you go. Sound good? Pretty good stuff, right? Really neat little tool available in the calculator. So just to give you some additional practice, if we went through and did another one, so let's see, let me move this over. So let me hit AC. So what we're going to do is we're going to look at another equation. So we've got x squared minus 6x plus 4. Now I hit the AC key to just sort of get out of that table mode, and you notice, again, we're still in that table entry mode in the calculator, so it still thinks it's ready. Okay, let's do some more graphing. So because the calculator stores our last operation, that's the values that it stores, it still has that last equation that we utilize, the x squared minus 2x plus 2. So instead of typing all that out, what I can do is I can say, well, why don't I just change the constants? Why don't I use the arrow key to go right here and just change that to a 6? So just delete that and hit 6. You see what I did? Then use the arrow key, go right here, and change that 2 by hitting delete and change that into a 4. See that? I'm lazy. I don't want to have to retype the equation all over again. I'll just change what I need and hit enter. Sound good? So hit equals. I don't need a gx or g of x. Start at -2. In this case, we're going to end at 8. Excuse me. And then our step, we'll do a step of 1. And there you go. And you can see when it's all said and done, your values should look something like this. You should have a -2, should be 20, -1, 11. So notice the step, it's stepping in increments of 1. So it starts at -2 and just keeps adding 1 over and over and over again until we get to 8. All right? And then once we have that lined out, just literally calculate this function for each one of those values and plot it out. And ultimately, you should get a curve that looks something like this. Again, the curve should make sense, based on what it looks like. I mean, we've got a parabola. It opens upward. So ultimately, that should make some reasonable amount of sense. Any questions? Yes, sir.
On the homework, so like the plotted part, you just do like a basic graph, or do you need like all the points, or basically just get
Well, that's a good question. So for the homework, essentially what you're going to want to do is just use the ranges that are listed for those problems and just plot those points. Because those problems should say, here's the equation you're graphing, and then here's the starting and end value, and here's the step. So you just go off of that. That's a good question. Any others? Anything else? Questions about life? Anything?
Don't screw up and put a negative step in. Calculator doesn't like that.
Yeah, it does not like negative steps. Here's this. All right, you get a chance to hand that out. All right, if that's the case, then, this is a little bit of a short lecture because that's really all that we're going to talk about with the Casio, at least in class. Now, let me be clear. The Casio will do quite a bit more. Like if I go back to, mode and 1, go back to computational mode. So for instance, here's an idea. Let's say I'm in the wonderful world of calculus and I want to do an integral. There's a button right under alpha that will allow you to start doing integrals. So if I want to do the integral of, let's say, alpha x squared, and I want to do that integral from 0 to 1, it'll do that for you. So I know you all probably had your limit with all this calculus stuff. Yeah, I don't get what the resistance is with all this calculus. I mean, it's just so integral to everything that you do. I know, really bad, cheesy jokes. I mean, you civil majors, you're in for a whole lot more. I mean, you're going to have me for at least 2 or 3 more classes. So everybody's like, electrical engineering's starting to look pretty good, right? A few other things that are worth mentioning. I know we're sort of done with lecture, but I did want to mention a couple other things. So for instance, you've got your sine, cosine, and tangent. Be aware that, if you hit shift and sine, you've also got your inverse sines, cosines, and tangents, and what have you. Over here on the right, you've got, not only do you have exponents and natural logarithms, you have logarithms to any base, so you can do a base 2 logarithm, a base 3 logarithm. How many folks have had or are in Calc 2? Okay, so if you're in there, if you hit shift and log, that should be pretty familiar. You know, summation notation. So the calculator will do basic summation for you. And it'll also do products as well. So if I clear this out and I hit shift, or no, sorry, hit alpha and this, there's a product as well. Have you all seen this before in calculus? If you are in Calc 2 now, you will see it. So bear with me, but you will. A couple other things. How many statistics folks do we have? How many folks have had statistics? You're in it now. So you'll see, first off, there is a host of things that the calculator will do. It will handle combinations and permutations. It'll do basic statistics for you. Like if you plug in a data set, it will compute averages and standard deviations and things like that. One thing I will probably do, and I haven't gotten around to doing it yet, but I think I'm going to try and at some point start knocking this out, is I'd like to post a few sort of what I'll call snippet videos. And you know, I'll say, here's how you do an average. Here's how you do a median and a mode and a standard deviation. Here's how you do a normal distribution on the calculator. Here's how you do an integral and all of that. So be on the lookout for like a little playlist that, you know, I might post it on MU Online. Just, you know, these little things like, how do you do this? How do you do that? And hopefully that'll help out, not just in here and in your other classes, but down the line when you're in differential equations and you can't quite remember how to, you know, take a sign or something. So hopefully that helps out. Any other questions?
Does one need a cover sheet too as well?
That's a good question. In terms of a cover sheet, I'd say no, because this one, everybody's just sort of filling out that. So, sound good? All right, so here's what I'm going to do. I'm going to shut up and let you all work on your homework assignments. I'll be in here hanging out, so if you got any questions. And that's really all I've got. So if you're finished with everything and you want to leave, that is totally fine. All right.